Hello Internet, welcome to ipL. My name is Andreas and today we are talking about the real-time distribution system or RTDS of the London Stock Exchange Group. Before we kick things off, a short disclaimer. This video is not sponsored by the London Stock Exchange Group. Its purpose is to educate interested parties and answer some of the frequently asked questions that I've come across in the recent years. Content accuracy is held to the best of my knowledge. For any questions and/or consulting and coaching requests, please post in the chat and/or contact me via the form linked in the description. As mentioned, today's topic is RTDS, the real-time distribution system of the London Stock Exchange Group, LSEG for short. Some of you may know the system by one of its various previous names, like TREP, the Thomson Reuters Enterprise Platform, or RMDS, the Reuters Market Data System. Others may have never heard of it and are just curious. So, in a nutshell, RTDS is a server-based solution to distribute data to a greater number of consumers and users. These consumers can be people or other data processing systems and databases. Most commonly, RTDS is used for the control, transformation and distribution of financial market data. What is financial market data, you ask? That's stuff like share prices, bonds data, commodities prices, currency exchange rates, but also news around all of these. The list is much longer, but going into more detail would take a lot of time and can be part of another video. What did I mean by data control, transformation, distribution? Examples of such functionality are slowing down of the data rate, also referred to as conflation. This means instead of getting, for example, 1,000 updates per second for an instrument, you can slow down the rate to, say, 1 update per second. The human eye can distinguish up to 3 updates per second. Anything beyond that is wasted network and computing capacity. Professional applications, of course, can process significantly higher data rates, but not all of them need these high rates. Next, making calculations on the basis of the data, also referred to as transformation. You can create your own rates that fluctuate with the underlying base instrument price. Or sending your own data to the world, also referred to as contribution. This is like advertising your services through the reach of the network of your vendors. Or restricting access to the data through access control. You may not want all your employees to have access to all data for various reasons, cost control being one of them. We will look at all of these in more detail towards the end of this video. To help understanding how RTDS works, we will put it next to a home entertainment system. People often sign up to multiple sources or services like Apple TV+, Netflix, and your standard TV channels. Similarly, companies often sign up to data feeds from multiple data vendors to get the best of all worlds. Examples here are London Stock Exchange Group, LSEG, Bloomberg, BBG, and the SIX Group. At home, you usually consume this via the internet or cable. In the corporate world, the internet has become more popular over the past decade, but often companies still prefer private network connections, which are dedicated leased lines that increase reliability and security significantly. Through this network, the information is fed into distribution devices. At home, you usually consume your services through something like a set-top box from your service provider, an Apple TV device, a DVD player, or the receiving module of your smart TV. In the corporate world, this is where the real-time distribution system, the RTDS, has its home. Like your home receiver, it collects all the different sources and then distributes them to the consumers, only that these aren't TV sets, but rather personal computers or other server solutions. I'm not sure it would help much comparing RTDS components to circuit boards in a set-top box, so let's remove our home entertainment system for a moment and look at them by themselves. RTDS comprises of two components, ADH and ADS. I can almost hear some of you going, but hang on mate, our RTDS has more components than just two. These other components are add-ons, and we will look into them in some more detail in a moment. So RTDS has two components, one for receiving data and one for distributing it. ADH, the Advanced Data Hub, is the component that receives your data feeds, which can be streaming or snapshot data. What's the difference between those two? Streaming data you can compare to a movie, i.e. a motion picture, whereas snapshot data is you looking at photographs, a snapshot of a moment in time. ADH can connect to multiple data feeds, so you will need to give each of them a name. Historically, many clients will start their feed names with IDN, which was the acronym of the old Reuters data feed technology. So the name could be IDN_bank, but it could be pretty much anything, because what is important is that you and your users know what data they are consuming through this feed name. ADH will then provide this feed to the ADS, the Advanced Distribution Server. End users and other applications will connect to the ADS and commonly never be aware of the presence of the ADH. This brings us to the ADS. The ADS receives the feed from the ADH and the connections from the users. Users are connecting to the ADS to request data, and the ADS then sends the response back with the requested data. This next section is about RTDS variants, which there are two of. One variant works with multicast. This is the actual RTDS, highly scalable, but with a somewhat more complex network setup, while the other one works on peer-to-peer principles, and it is called Real-Time Connector, or RTC. It has a more straightforward network setup, and for that reason public cloud services like it a little bit better than RTDS. Some of you may wonder what that is to you. In many cases, either of them will be fine for you. You won't notice a difference. What is multicast, you ask? Okay, how do we set this up? Let's get a garden, some trees, and some children. Imagine you're calling your 7 children to stop playing and come in for dinner. You open the window, take your megaphone, and shout your message into the garden. This isn't multicast yet, this is broadcast. Like your radio station, they send their message and hope somebody will hear it. Multicast is when your children then respond, coming, me too, me 3, and so on. So you send a single message that is heard by the entire neighborhood, and you expect your children to respond that they heard you and hope it's only them coming for dinner and not your neighbors as well. Simplified for RTDS, this means an ADH or multiple ADHs can send a message to a subnet, your garden, and all ADSs, i.e. your children, in that subnet can receive this message. So if one ADH fails, for example, you lost your voice, the other ADHs, that'll be your partner, will continue to send the message or scream out of the window, respectively, and your operation will continue without impact. Your children will come for dinner. How does this work with RTC? Well, this is a bit more laborious, and the analogy is something for rich parents because you would pretty much pick up your phone and call each of your children individually on their phones, and we know how much smartphones cost. I leave it to you to figure out how to do this with a toddler though. Luckily, your neighbors won't know that the table is set. For RTC, this means each ADH sends its message directly to connected ADSs, i.e. calling a phone instead of shouting out of the window. If the ADH is down, like you have lost your voice, the ADS may call Houston to report a problem because it does not receive any data. This is unlike your children who will just continue playing until they grow hungry. Commonly, ADSs are configured for more than one ADH in a resilient setup. However, when it has to switch from an out-of-order ADH to a secondary ADH, there will be a brief interruption of your operation, like when you have to signal your partner to make the calls to your children on your behalf. Why are there two components and two variants instead of just one respectively? Scalability and resiliency are the main reasons why. Let us look at it in a little more detail and start with multicast. Add a few more servers, remove that connection between ADH and ADS and add a multicast network segment and have all these components connect to it. Now that is said, let's look at scalability and resiliency. Scalability is a factor because you may have so many users that a single server will struggle to cope with all the requests. With more ADSs, you can load balance your users by connecting some of your users to one ADS and others to another. On the right-hand side, you see two servers that have both components installed, which is a very common setup. On the left side, there are dedicated servers for only one of the components at a time. These can be in the same location or located in different cities, different countries, even different continents. Because all components connect to the multicast network, you can add or remove an ADH or an ADS or both without impacting operation and thus scale exactly to your requirements at any point in time. Really, you ask? Yep, because these servers can either be physical hardware or virtual machines. Note that removal of an ADS with active users on it will still interrupt operation because their application will take a moment to connect to a secondary configured ADS. You should move them to a different ADS first, which of course is not an option in case of a server failure. Next, resiliency. There is no perfect technology, and either a server or a network segment or a building may fail, and you would still want to be able to continue working. By spanning this multicast network across larger geographical distances, you can be quite certain that no single event, be it a crashed server, broken down telecommunications network, or a natural disaster, will bring your business to a grinding halt. For a look at peer-to-peer connectivity, let's remove the multicast network segment and change the connections between the components around a little. You can see that there is no immediate connectivity between the servers in Europe, North America, and Asia. For reasons of resiliency alone already, we need to configure each ADS with a connection to at least a second ADH. As we are looking at what develops to become a map of the London Underground, you are going to ask how this can be considered more simplistic network configuration. From a network standpoint, one-to-one relationships are easier to manage. From the point of view of the engineer configuring the servers, this requires indeed more effort. This setup is also well scalable and resilient. However, it is more fidgety in server configuration, and failure of an ADH is more likely to cause disruption, even if it's just for a couple of seconds while connections to secondary servers are established. ADS resiliency is identical to multicast setup of the actual RTDS. As you can see, there are advantages to both variants, depending on your use case. Now it is time to come back to, but mine is bigger. I mean, my RTDS has more than 2 components point mentioned earlier. I picked out 4 add-ons for this exercise, but there are more available. Most RTDS are sold in conjunction with DACS, the Data Access Control System. However, you could use your RTDS without a DACS, just the same as you could use a DACS without an RTDS. Using RTDS without DACS would expose you to potentially expensive data invoices, as you would either need a different means of data access control, or you'd be paying for all users that have access to data from the RTDS. Again, most RTDS are also sold in conjunction with a contribution component like contribution return or contribution channel server. The latter is configured directly in RTDS, while the former is a separate piece of software. Contribution is important as it allows companies to use the network of their vendors like LSEG, like Bloomberg, like SIX, etc. to advertise their prices to a much larger audience. If you're dying for a home entertainment analogy, don't worry, we'll go there again shortly. DPS, or Database Publishing System, is a module that allows you to feed any data from a flat file, CSV, or an actual database. This is useful for companies who, for example, want a single output system, i.e. the RTDS, for a multitude of feeds instead of having to configure applications for multiple feeds separately. The last but not least on this list is the Advanced Transformation System, or ATS. ATS is what can probably be quite aptly called server-based Excel on steroids. It allows you to calculate values from just about anything, but also from the feeds provided by RTDS. You could automatically create a new sales rate that already contains your margin, so you can ascertain that all your salespeople are providing a consistent price to your clients. And you remember that I used sources from 3 different vendors, LSEG, Bloomberg, SIX. You could also use ATS to compare rates between these and identify which vendor carries the most liquid one of a given instrument, i.e. the one that receives most updates, asks, bids, trades. Naturally, when you're trading, you would want information that is closest to the market, so liquidity of an instrument is important. Finally, back to our home entertainment system analogy. Let's grab a TV set. First, we want to look at what DACS might look like at home. What do you think would it be? Correct, parental control. You want to restrict your 7 children from viewing some content because they might max out your credit card? There you have it. Next, a look at DPS. This would be you connecting your phone or camera to your TV set to view your holiday photos. Remember, DPS is for static, snapshot, moment in time data, just like photographs. Then we have ATS. A close analogy could be this video here. I took information from various sources. Well, my brain mostly, but that got it from the official documentation, conversations with knowledgeable people, and client experiences. I then transformed it and can now watch it as my own creation on my TV. And finally, the fact that you can see this video means I then contributed it by uploading it through YouTube Studio so that more people can enjoy it than just myself. You've made it all the way here. I hope you found this video useful. Please leave a like if you got some use from it, and a comment what you liked, what you didn't like or miss, and what you would like to see in future. In the description below you will also find a link to a feedback form in case you want to get in touch, are interested in consultancy or coaching, or if you have a topic that you would like me to cover and want to provide more details than the comments here allow. Thank you so much for sticking around until the end, and I hope to see you again soon.